Good morning, ladies and gentlemen. We're going to do partial fraction decompositions today. This is part of Chapter 6, but this is a tool, I think that's true, may not be true, but it's a tool that we're going to use in managing our integration techniques. We learned this in pre-calc, but I'm going to remind you, and then the way that I'm going to teach it is with matrices instead of solving the systems by hand. So I'm just going to do 2 or 3 examples and then we'll be good. So the first example, I have 5x minus 1 over x squared minus 2x minus 15. And in calculus, this might be the way our problem looks. If I tried to do use substitution, that's just going to get weird because things just don't line up. So instead, I'm going to separate it into individual rational functions by using the partial fraction decomposition. So I'm just going to manage the function for right now. I'm going to write this in its factored form, plus 3, okay? And now when I separate this, both of these are linear factors, so I'm going to write a over x minus 5 and b over x plus 3. I'm going to multiply both sides of the equation by the lowest common denominator. So I'm going to start with this side. I'm going to have a times x plus 3 plus b times x minus 5 is equal to 5x minus 1. I'm going to distribute ax plus 3a plus bx minus 5b is 5x minus 1. The goal is to solve for the a and the b, so I'm going to start writing a system of equations based on degree. So I'm going to put these guys together, 5x, and I'm going to mark them off because I've used it, and then I'm going to do 3a minus 5b is a negative 1. Since I'm solving for a and b, and because you can't put variables in your calculator, I'm just going to write the coefficients. So this is 1, 1, 5, 3, negative 5, negative 1. So now what I'm going to do, hopefully the calculator will work this time, is I'm going to go to my matrices, I'm going to edit A, and then the size is a 2 by 3, and my matrix is 1, 1, 5, 3, negative 5, negative 1. And I will tell you that the biggest mistake that happens when you're doing these is entering your data wrong, so you always want to make sure that you second check it. I'm going to quit. I'm going to go back to matrix. I'm going to go over to math, and then I'm going to go way down to RREF. Oh yeah, you're starting to remember pre-calc. Then I have to tell it which matrix to do RREF on A, and I hit enter. And this is my solution matrix, which says that A is equal to 3 and B is equal to 2. So now if you notice, I can go ahead and rewrite the integral. So the original integral was 5x minus 1 over x squared minus 2x minus 15 dx. Now I can write it as 3 over x minus 5 dx plus the integral of 2 over x plus 3 dx. These are considered the partial fractions, but what it's done is made your integral now very easy to manage. Alrighty? Alright, that was the first example. Whew, that was a whole first page of writing. Now let's do a slightly different variation. Okay, scoop my paper up. This time we're going to have a different type of denominator. So I'm going to have the same basic function, and I'm going to have 5x minus 1 over x squared times x minus 3. So, and we'll just assume that it has an integral and a dx, because really all we're trying to do is just manage the method of partial fraction. Anytime you have a factor that's raised to a degree, that means that when you set up the partial fraction, it's going to be a over the first degree, b over the second degree, and then I would have my c over x minus 3. When I multiply, and put it in there, both sides of the equation by the lowest common denominator, then the A would get multiplied by one of the x's and the x minus 3. The B gets multiplied by the x minus 3, and the C gets multiplied by the x squared. All right, and I'm just going to finish this example just in case you need to see it again, and I'm going to write 5x minus 1 on this side. I also usually would write x squared minus 3x so I don't make a math mistake. When I distribute, I'm going to get ax squared minus 3ax plus bx minus 3b plus cx squared equals 5x minus 1. Okay, here's my a squared, so I'm going to take a shortcut. I'm going to jump straight to the matrix. There's not a b squared term. There's a c squared term, and then it equals 0. Okay? So that was my squared equations. Now I'm going to do a negative 3. I'm going to do a 1. There's no c, and I'm going to put that that equals 5. Okay? Keep scooting up so you can see. Now I need to do my linear. There's not an a. There's a b. There's not a c, and it equals a negative 1. Right here, you can see that you can solve for b right off the bat, but to save myself some time, I'm just going to go ahead and drop this into a matrix. Okay, let me put it over here so I can see while I do it. So I'm going to go back to my second matrix. I'm going to edit, and I always edit A. This is a 3 by 4, and I have 1, 0, 1, 0, negative 3, 1, 0, 5, 0, 0, negative 1. I check it, 0, 1, 1, 0, 0, 0, 5, negative 1. I quit. I second enter. Ooh, that's yucky. And then I get that A is equal to a negative 1.556, B is 0.333, and C is 1.555. So what happens when I make up problems? The numbers don't turn out very well. But even so, I can take these coefficients, substitute it in here, and then take my original integral and split it into 1, 2, 3 different integrals, including your dx, of course, and then I could integrate each system. All right, I have one more example for you, and again, it's just a slight different variation. This time I'm going to have the integral of 2x cubed minus x squared plus 5x over x squared plus 1 quantity squared dx. And so here's what makes this one different. Number one, I have a power. Number two, this is irreducible over the real, which means that when I try to solve for x, I get an imaginary number. So when I set up the partial fraction decomposition, it's going to be ax plus b. Anytime you have something that's irreducible, it turns into this, over x squared plus 1, and then plus, and I just keep using letters of the alphabet, dx plus d, and then I have x squared plus 1 quantity squared. So now I would be ready to run my partial fraction. So again, I'm just going to show you in case you need another example, and I'm going to multiply it by x plus 1 squared. So the ax plus b is going to get multiplied by 1 of the x squared plus 1, and then the cx plus d is going to get multiplied by nothing. Okay, and then it's going to equal 2x to the third minus x squared plus 5x. So when I do my multiplication, I'm going to get ax to the third plus ax bx squared plus b plus cx plus d is 2x cubed minus x squared plus 5x. Now I'm going to go ahead and include the cubic thing because I have a cubic over here, and I'm going to jump straight to the matrix. So I'm going to write 1, there's not a b, there's not a c, there's not a d, and then there's a 2. Yes, I know that a is equal to 2, okay? And then I'm going to set up my linear. So I use this one, sorry, I'm going to do my quadratic one. So then I have a 0 quadratic, I have a b quadratic, no c, no d, equals a negative 1. Well, and I'm just going to write this as I go. I know A is 2. I know B is a -1. So I did cubic, quadratic. Now I'm going to do linear. So I have an A. I don't have a B. I have a C. I don't have a D. And I have that it equals 5. Okay? So technically I would have to solve for C. And then D, constants, there's not an A, there's not a B, oops, I lied. There is a B, there's not a C, there's a D, and then there's a 0. So because two of them are undone, I'm going to go ahead and put the matrix in my calculator. So this time I have second matrix edit. I'm going to edit A. I have a 4 by 5, and I'm going to do 1, 1, 2, 3, 2, 0, 1, 0, 0, 1, 0, 1, 0, 5, 0, 1, 0, 1, 0. Then I'm going to check it. 1, 0, 1, 0, 0, 1, 0, 1, 0, 0, 1, 0, 3 zeros and a 1, 2, -1, 5, 0. Enter. I'm going to quit. Second enter. And if you'll see, I got A is 2, B is a -1, C is 3, D is 1. And so now I can substitute these in to my integral. So my integral overall would be 2x minus 1 over x squared plus 1 plus 3x plus 1 over x squared plus 1 squared, and then dx. And of course, then I could split it up into two integrals and then manage it from there. So it's a lovely little technique that just helps you to manage different types of integrals that are a little bit problematic. That's it for today. See you soon.